Hello and welcome to the next part of this polar coordinates videos. Okay, so third one we're doing where we're going to work out area enclosed by the polar curves. Right, the formula is area is equal to half r squared d theta, and then you have obviously the two limits of the theta. If you want to work out area enclosed, like in this question, by the whole curve, this will be 0 to 2 pi. If you want to work out area of a sector, then that will be two different angles from wherever the sectors begins and sector ends. Right, guys, the steps for this one is we work out r square first, then integrate it, and then substitute the values in. This is a question I picked up, exercise 5C, question 2. It says show that question. And I would probably say to you, majority of the questions you get in exam will be show that questions. Okay, so we will now work on it now. Okay, the step one is we're going to work out r square. Okay, then try how do we integrate this. Okay, so this is r. Let's work out r square. I'm going to pause it and you can do it yourself as well. All right, guys, so this is my r square. I'm pretty sure if you've done p plus q cos theta times p plus q cos theta, you will get the same answer. I just use my normal in this. Okay, so now we're going to be working out the area, which will be half, and then a squared p squared plus q squared cos squared theta plus 2p cos theta, and from 0 and 2 pi. Obviously, like we always do, I will do this integration separately in parts and then put the values of 0 and 2 pi a little later. So guys, I'm going to be rearranging. So this is half a squared. That's common to everything because a squared will come out anyway of the integral. Then we got p squared d theta. Then I got, if I take q squared as a constant as well outside the integral, q squared, then it is a cos squared theta d theta. And if I take 2pq common, that will be cos theta d theta. Guys, these are the three integrals. I'm going to put the values in later. Really important. The most important part in here is if you haven't done integration in normal maths, then you will be struggling to work that out. If you have, guys, cos squared theta before integration, we need to set it up, marinate it, and this is half plus half cos 2 theta. Right? Similarly, if you had to do sine squared theta, that would be half minus half cos 2 theta. And this is nothing but rearranging cos 2 theta formula. All right, guys, let's start working on these integrations now. Right, so this is p squared theta, q squared is outside, so this will be divided, split into two parts. So this gives me half theta and plus 1/4, remembering reverse of chain rule integration, and sine 2 theta. Who have done this right? And for that one, this gives me 2pq, and cos theta's integration is sine theta. Okay, and that's it. This is what the answer is. Now let me just write down in simplified form a little bit if I can, then we could start putting the values in. Look at it. I've just, I don't know why, but I just organized, corrected this theta terms together. I want to put the values in 2 pi and 0 in it. Okay, so one by one, you can do that as well, guys. So that is, I'm going to write down two values here. Okay, so you can do it yourself. I substitute x theta equals 2 pi there, substitute theta equals 0 there. See what do we get. Okay, just save the time to try this yourself. This turned out to be a classic example because sine of 4 pi is 0, sine of pi is 0, sine of 0 is 0 as well, and this is 0. So I get just this term, which gives me half a squared and times with, if I take pi common, let me just pi over 2 here, and that gives me 2p squared plus q squared. Okay, so what do I get, people, in the end? This is 2p squared plus q squared over 2 pi a squared. And that's what we wanted to prove. This is where our target was. That's area of whole curve, area enclosed by the whole curve. Now we're going to do a couple of questions with the sectors now. The next question which I've picked up is actually very, very important. This is exercise 5C, question 5. So pause the video for a second, have a look at the question and try and understand it. There's two curves, r equals a sine 4 theta. That's this big fat one, blue. and then r equals a sine 2 theta. This is the thin one there, and theta is between 0 and pi over 2. So have a look at this question. We're going to work out the area enclosed between these two curves. Guys, this is where the geometry comes in. So I'll give you time to have a look at this question. Like I've said this to you in my previous video, we want R to be positive, okay, especially in Excel. And then what is the domain of the values? And sine theta or sine of any angle is positive when it is between 0 and 180. Remember that cast diagram? Okay, so sine's positive here and there. Right, so sine 4 theta, for R to be positive, we want sine 4 theta to be positive. What does that mean, guys? The theta could be between 0 and pi by 4. Because as theta is pi by 4, the maximum value, that gives you sine pi positive. The moment theta becomes more than pi by 4, this R will become negative. That means the domain of this function within the domain which is given to me for theta is actually this. And with this one, that's fine. This is 0 and pi by 2 because maximum value is pi by 2 will give you pi, and sine R will be positive there. Right, so now we try and work out the points of intersection between these two curves. Remember, the points of intersection, looking for values of theta. I can clearly see they meet at origin or the pole. By the way, that means theta should be equal to 0. Let's see what that value is. Let's see what the other three values are, guys. So try and solve these two equations. So how do I solve these two equations? It is a sine 4 theta is equal to a sine 2 theta. Let's try and solve this. I give you time, you do this, then we do this together. Right, so here you are. Can we first divide them by a? I get sine 4 theta is equal to sine 2 theta. Then I take using inverse function. So 4 theta is equal to 2 theta, taking sine inverse on both sides. Right, so my cast diagram, 4 theta is equal to pi take away 2 theta, because if that's first angle, second angle will be here, pi take away that. And guys, I know this is a periodic function, sine and cos. I'm going to add a multiple of 2k pi in there. And 4 theta would be equal to just 2 theta as well, and plus 2k pi, because you know sine, cos, and periodic functions have periodicity of 2 pi. Right, let's try and work out the value of k theta from there, and which comes out as this. So these are the two values of theta we get. You can take a pause and check, and k can be any integer. Okay. Now, guys, we're looking for, because our domain of theta was between 0 and pi over 2, we'll be looking for all the integers which give me value between 0 and pi by 2. So, guys, when k equals 0, the point of intersection, I get what? This is 1. So theta is equal to pi over 6 from here. I get theta is equal to 0. Both are within the range, okay? And when k equals 1, I get what here? 1 plus 2, 3, 3 times pi over 6. I get theta is equal to pi over 2. And this is theta is equal to pi. This I cannot accept, okay? So these are the three values, because as k gets bigger, the value is going to get bigger from here, okay? Three values now. Now, very important, guys, very important. So three values, theta equals 0. I can see theta equals pi by 6. That looks like this one, okay? And then theta equals pi over 2 is coming back over here again, okay? But now my first curve, r equals a4 sine 4 theta, was only allowed to go pi by 4. So I'm pretty sure for this curve, after pi by 4, the values of r is going to be negative. Okay, so this point is theta equals pi by 4 for that curve, for r equals 4 a sine 4 theta. That's right. So we're going to discuss this now, people. Listen very, very carefully. I'm going to show the geometry of this. I'll try and make this diagram again and show how do you work out this area. Okay, so hold on for a second. Let me draw the diagram again for you. Okay, for the first curve, the bigger one, okay, we know this is pi over 6, right? So I will need to work out, if I split this into two parts, I need to work out that bottom part, which will be 0 and between 0 and pi by 6. So that means I'm going to be integrating that bigger curve. So which will be, I'll write here, we'll write on neat later on. This will be a sine 2 theta squared d theta half between 0 and pi by 6. And that gives me the area R1, which I've shown you here. Okay, now I'm going to show you what part of the red curve we need to integrate so that we get the other part of the required area. So for R2, that red curve, which is a sine 4 theta, I have to do R squared d theta, integrate half outside, but very, very important, people. I want to go, this curve goes from 0 and goes up to pi by 6 over here, and this is pi by 6 over there as well. So I want to go from pi by 6 and to pi by 4, because this curve does not have a value, positive value of R, when angles between pi by 4 and pi by 2, we discussed that here. So at theta equals pi by 4, this come back to 0. This is pi by 4. Right, so these are the two integrals. We need to add them, and then that will be the area of this whole portion R. Once again, for the red curve, guys, from pi by 6, because this is from 0 and going on, we got pi by 6 over here, and from pi by 6 to pi by 4 when it comes back, that's up to this point. That's the area we need to work out. So the integrals now, people. So let's do this in parts, people. So I'm working on R1 first, the bottom blue region. Okay, this is half, that's half. A squared, I'll come bring it out, sine squared 2 theta d theta, and I want to do what half a squared, use my cos double angle formula, that will be half minus half cos 4 theta. Okay, so I'm going to integrate all of that now. So with that, what does that give me? Half a square is outside. This is theta over 2 for that, and minus 1/4 sine 4 theta. Okay, and then the limits are 0 and pi by 6. Let's put the values in, see what do we get in here, guys. This is the next line. I've substituted pi by 6 over there. I get that. And I'm going to simplify this to see what the answer for R1 is. And that should be the answer for R1. We move on to R2. So I thought this is the value of R1. Okay, I'm going to work out the value of R2 now, and we're going to add them together. So guys, same thing again. Can you just work this out yourself? This is a 4 theta there. Okay, so let's see. Comes out in 8 theta. Then let's work it out separately over here, people. Then we add it. Okay, so I will be working out here half. I'll put the limits later. This will be a squared sine squared 4 theta integrated. Okay, using the same formula. This is a square over 2. And bracket, I'm going to integrate it half minus half cos 8 theta, double of that. Okay, lovely. D theta. Let's do the integration, put the values of these two limits, see where do we go. Just try to save time, people. All right, so while I was working on it, I just realized a mistake here. The integration of cos 4 theta would be sine 4 theta divided by 4. That should be 8 there, because that probably changes a lot of things after that. Okay, and so 1/8 there for me, and that gives you 32, I think. Okay, hope that helps me. So guys, this is my integration over here. So cos 8 theta integration sine 8 theta divided by 8, that gives 116. Put the values in, see what do we get. So carefully working out, this is what I have got. Hope that's right. After putting the values in, well, that gives me 0, because 2 pi it is, sorry, and 4 pi over 3 is, again, it's root 3 over 2. 4 pi over 3 has been negative now. Yeah, this is 240, that's my negative answer. Okay, so then we work it out, and we get an answer from here, guys. I don't know what the answer is. Add these two together, you should get match the answer. Okay, we can check. I don't want to waste too much time to make the video longer. Check if the matches the answer. If not, let me know, we can do it again. Next question I've decided to do is question number 9 of exercise 5C. You can see the question in an Excel book. Those who do not have the book, they can take a pause, take a picture of the question. It says a diagram shows the curve. That's a curve with the polar equation this. and theta is between 0 and pi over 3. And at points A and B, the value of R is this. So points A and B, value of R is given to you. That means you know R here, you know R here. Okay. Point A lies on the curve and point B lies on the initial line, right? Find character 3 significant figures, the finite area bounded by the curve and the line. So what I see from here, people, I'll have to do what? I have to work out the area of the sector for this curve from theta equals 0 to theta equals this point, right? If I join a line there, right? So I have to work out the area of that sector and take away from that area of this triangle. I should get the answer, right, guys? So this is what this task is. Let's see if we can, how can we handle this now? And right, so let's try and work out the polar coordinates of A. At A, you know R equals 2 plus root 2. So at A, because it's in the curve, this is the equation. That means we're going to be solving these two simultaneously. So 2 plus root 2 over 2 is equal to 1 plus cos 3 theta. Right, simplifying, that gives me root 2 over 2 is equal to cos 3 theta. Okay, and 3 theta is equal to pi by 4, the principal value, and secondary value we don't need to go because secondary value of the cos will come in the fourth quadrant, and theta is only between 0 and pi over 3. That's the only value we can take. So theta is equal to pi over 12. That means at A, theta is pi over 12. So guys, the sector I need to work out, which I was trying to say, I need to work out the area of this sector and take away area of the white triangle from there. So I need to work out 1 plus cos 3 theta whole square 3 theta half between 0 and pi over 12. Then take away from it area of the triangle OAB. Right, so this is basic integration. One more time, we pause it, save time. Let's see if you can, you do it yourself and I'll match the answer. This is your next step from there. Just multiply out the bracket. Obviously, this is basic integration. This is basic integration as well. Obviously, reverse chain rule, remember. And this one, I need to change using that cos to a formula that will be changed as what? Half plus half cos 6 theta. So guys, we integrate all of these and we put the limits back in. So pausing it one more time and see if we can match the answer. Check carefully. This is my step-by-step integration. One's integration is theta. 2 cos 3 theta's integration is 2 sine 3 theta divided by 3. Then half integration is half theta, and half cos 6 theta's integration is half sine 6 theta divided by 6, which is 1/12, right? So simplify, put the values in, limits, and see what the answer is. Right, so this is between 0 and pi by 12. So put the values in, right? I can see clearly, guys, they're all sines, and sine 0 is 0. So that means the second bracket will not matter, but I will probably still show it, okay? This is 3 over 2 times pi over 12 plus 2/3 sine pi by 4. 3 times pi over 12 is pi by 4, okay? And plus 1 over 12 sine pi by 2, yeah. Okay, and take away 0 and put these values in to work out an answer. Let's see, what do we get there? So I put that in the calculator and let's see, what do I get? So this is something I get. I hope that's correct answer. There'll be an answer. Check if there's no mistake in calculation there. Then what do I do after that, guys? I have to take away the area of the triangle. Area of the triangle is this. It's an isosceles triangle. They told me R equals 2 plus root 2 over 2. This is 2 plus root 2 over 2. And this is pi over 6. We just use half AB sine C and put this value in. So take away from this answer, take away that, and write final answer to 3 significant figure. So guys, this is another question which involved a bit of geometry and a sector, okay? Right, to sum it up, this was our third type of questions, finding area enclosed by curves in the area of sectors, including geometry. This was the formula we've been using. And, with the curve, you take limits 0 and 2 pi. So that's it, guys. With this, we'll finish, and we'll come up with the fourth video, which is about the tangents. All right, guys. Thank you very much. Bye.